Hey guys, welcome to my YouTube channel. Today we're going to be looking at how the presynaptic neuron releases neurotransmitters. So here I went ahead and labeled everything for you. The presynaptic neuron is the neuron before the synapse. Here the synapse is just a gap of space between the presynaptic and postsynaptic neuron. The postsynaptic neuron has receptors here that bind to neurotransmitters released by the presynaptic cell, and when these neurotransmitters bind to receptors in the postsynaptic cell, it initiates some type of excitatory or inhibitory response depending on the type of neurotransmitter. On the sides of the presynaptic neuron, as you can see here, are the voltage-gated calcium channels, and these will be really important in initiating neurotransmitter release. So let's take a look at what happens, the events that happen that causes the neurotransmitter to be released. Also note that this is a type of chemical synapse. There's also something called an electrical synapse where the two neurons are connected by gap junctions, and basically their cytoplasm is connected, and that's another way that neurons can communicate, but this type, the chemical synapse, is the most common one, so we're going to be looking at that today. So first step, what happens is an action potential arrives at the synaptic knob. So the synaptic knob is this area here. This is an axon, and this is the ending of the axon. And this place, the synaptic knob, is where neurotransmitters are located. And so yeah, the first step is the action potential is propagated across the axon, and it reaches the end of the axon at the axon terminal at the synaptic knob. Second thing that happens is that when that action potential reaches the synaptic knob, these voltage-gated calcium channels open, and that causes calcium from the extracellular space to move into the neuron. So calcium from the outside moves into the neuron. And the reason they do this is because the concentration of calcium outside of the cell is greater than the concentration of calcium inside the cell. And as you know, in biology, substances like to move down their concentration gradient. So when there's a higher concentration of calcium outside the cell and a lower concentration of calcium inside the cell, the calcium will tend to move into the cell. So this is the second step that happens. Third thing that happens is that when the calciums enter, it initiates, and it causes these vesicles with neurotransmitters to fuse with the membrane of the axon of the presynaptic neuron. And when it fuses, these neurotransmitters are released into the synapse, and these neurotransmitters will bind to the receptors on the postsynaptic cell. Fourth step that happens, number 4, is when these neurons, the neurotransmitters bind, it causes an excitatory or an inhibitory response. As I said before, these neurotransmitters will decide if the response is excitatory or inhibitory. So an example of an excitatory neurotransmitter is glutamate. And this neurotransmitter will cause the membrane potential of the postsynaptic neuron to go closer to threshold. So remember, when an action potential is initiated, the membrane potential of the neuron has to reach somewhere around negative 55 millivolts for neurons. But as soon as they hit this threshold, this magical number, an action potential will occur. So glutamate depolarizes the postsynaptic cell, and that causes the membrane potential to go closer to threshold, which means an action potential will be more likely to occur. Now, on the other hand, an inhibitory neurotransmitter, such as GABA, this inhibitory neurotransmitter will cause an inhibitory response in the postsynaptic cell, and that means that the membrane potential hyperpolarizes, and it brings the membrane potential further away from threshold and makes it harder and less likely that an action potential will occur. So now let's take a closer look at what happens when the neurotransmitter is being released. So here's a close-up of the vesicle and the membrane. So there are some proteins involved. These proteins are what keeps this vesicle in place when it's turn to be released. So here's everything labeled. This all takes place in the presynaptic cell. So remember, the presynaptic cell is the cell that releases a neurotransmitter. There are the snare proteins and the ℓ𝕗𝕐𝕗. I definitely pronounced that wrong. But these two are involved and they're connected to the vesicle. So what happens is that when the calcium ions flood in, remember when the action potential reaches the synaptic knob, the calcium voltage gated channels open and the calciums come flooding in. Well, now what the calcium does is it causes these proteins here to change shape. So these proteins will change shape and become more like intertwined and become like this. So it went from this to like this. And now it's like this, it changed shape, and it will make it easier for the vesicle to fuse with the membrane. So now, when it's fused with the membrane, the contents of the neurotransmitter inside the vesicle can now be released into the synapse. So if we take a look back at the original picture, the snare proteins here cause this vesicle to fuse, and the neurotransmitters are now released into the synapse, and these neurotransmitters can now bind to receptors on the postsynaptic cell. So let's do a review of everything we learned. So here are the labels for everything in this picture. First step, an action potential comes and is propagated down the axon and it arrives at the synaptic knob. The second step is that the voltage-gated calcium channels open and calcium ions flood in. Third step is the calcium ion causes the neurotransmitter, the vesicles with neurotransmitters to fuse with the membrane of the neuron, and the neurotransmitter is released, and the neurotransmitter binds to receptors on the postsynaptic cell. So yeah, thanks for watching.